Good evening and welcome to Physic for Sleep. Tonight we embark on an intellectual journey, exploring the fascinating concept of the edge of the universe, understanding why it is not a physical wall, but rather a profound horizon in time itself. Before we gently immerse ourselves in these cosmic depths, I would like to know where you are at this moment. Perhaps you are gazing out a window at the quiet city lights, or perhaps you are nestled in a comfortable armchair, a warm drink beside you, listening to the gentle rhythm of the night. If these deep reflections help you relax and organize your thoughts before sleep, please support the channel with a like and subscribe so others can find their way here too. Now, just breathe, allow your eyes to grow heavy, and let's begin. The initial concept many of us naturally form when contemplating the edge of the universe is often one of a tangible boundary, a cosmic wall, or an ultimate barrier beyond which there is simply nothing. We are accustomed to finite objects in our daily lives: a room with four walls, a book with pages that eventually end, a planet with a discernible surface that defines its extent. It is a deeply ingrained intuition to imagine limits in a spatial sense, perhaps picturing a vast dark expanse that abruptly terminates like the edge of a flat map, or even a literal cliff into an unknowable void. But the cosmos, in its grand and often profoundly counterintuitive design, transcends these familiar geometric constraints. The universe, in a truly profound and scientifically informed way, does not possess such a physical edge, a point where space simply ceases to be, or where one might hypothetically fall off into an absolute nothingness. Instead, what we perceive as a limit, a boundary to our cosmic view, is not a wall in space, but rather a profound and ever-shifting horizon in time. This horizon, often referred to as the observable universe, is a direct and inescapable consequence of two fundamental and deeply interconnected principles that govern the very fabric of our reality: the finite age of the universe itself and the constant, immutable speed of light. Light, that tireless and ubiquitous messenger of all visual information, travels at an astonishing yet ultimately finite speed of approximately 300,000 kilometers per second in the perfect vacuum of space. This fundamental constant, a cornerstone of modern physics, first elucidated by the profound insights of Albert Einstein in his theories of relativity, and rigorously confirmed by countless experiments and astronomical observations since, represents the absolute cosmic speed limit for any information or influence within our cosmos. There is, quite simply, no faster way for data, for events, for the very essence of what we observe, to traverse the immense cosmic distances between objects and ourselves. And since the universe itself is not eternal in its current dynamic form, but rather had a definite beginning, the Big Bang, an event estimated to have occurred approximately 13.8 billion years ago, the light from the most distant objects has only had that specific and finite amount of time to embark on its arduous journey across the expanding cosmos and ultimately reach us. Therefore, when we gaze into the deepest reaches of space with our most powerful telescopes, whether they be orbiting Earth or situated in remote terrestrial locations, we are not merely observing distant objects in their contemporary state. We are, in a very real and literal sense, gazing backward through the immense epochs of cosmic history. The light from a galaxy that is, for instance, 1 billion light-years away, presents that galaxy to us as it appeared 1 billion years in our past. The farther we extend our observational vision into the cosmos, the further back in time we are able to see, unfolding the universe's grand narrative, event by event, photon by photon. The edge of the universe, then, is not a physical frontier, a kind of impenetrable barrier that one might hypothetically encounter and peer over if one could travel far enough. Instead, it is a temporal boundary, a limit imposed by the very flow of time and the finite speed at which light travels. It is the furthest point in the past from which light has managed to embark on its journey across the immense cosmic expanse and finally arrive at our detectors, here on Earth, at this precise moment of observation. This ever-present limit defines our observable universe, a vast luminous sphere geometrically centered on us, the observers, stretching outward in every direction to the maximum distance from which light emitted at the dawn of time is only now making its arrival. Beyond this immense horizon, there might indeed be more universe, more galaxies, more intricate structures of matter and energy, perhaps even an infinite continuation of space-time. But their light simply has not had enough time to complete its arduous. The light from those most ancient of cosmic events, a journey spanning billions of years to reach our sensitive instruments, thus defines the very limits of what we can, in principle, ever hope to observe. This boundary, this cosmic horizon, is not static. It is constantly expanding as the universe ages, and more light from ever more distant regions has the opportunity to finally reach us. Yet it remains a horizon, a fundamental limit to our perception, a profound reminder that our view of the cosmos is always, intrinsically, a view into its past. And it is important to understand that this observable universe is not a singular, absolute entity that encompasses all of existence. Rather, it is inherently a personal and subjective sphere, centered precisely on the observer. Just as a ship on the vast ocean has its own horizon, which moves with the vessel, so too does every point in the cosmos possess its unique observable universe. An observer positioned many millions of light-years away from us would perceive a different set of galaxies and structures within their own observable sphere, many of which would lie beyond the reach of our current observations, and vice versa. They would be looking back in time from their own vantage point, witnessing a different tapestry of cosmic history. This concept carries a deep implication. There is no universal now in the cosmos that all observers can agree upon. The very fabric of space-time, as revealed by Einstein's relativity, tells us that simultaneity is not absolute. What is now for us here on Earth is not simultaneously now for an alien civilization in a distant galaxy. Their now could be our distant past or our far future, depending on their motion and gravitational environment. This means that the observable universe is not merely limited by light travel time, but also intricately tied to our specific position and timeline within the grand, four-dimensional expanse of space-time. It is a dynamic, evolving boundary, constantly expanding and shifting as the universe continues its grand, accelerated expansion. This expansion of space itself plays a crucial role in shaping our cosmic horizon. As the universe stretches, the very space between galaxies expands, carrying them further apart. This stretching also affects the light traveling through it. A photon emitted by a distant galaxy billions of years ago on its long journey towards us has its wavelength stretched or redshifted by the expansion of space. This redshift means that the light arrives at Earth with a longer, redder wavelength and consequently less energy. For objects far enough away, the expansion of space can be so rapid that the light emitted from them is stretched to wavelengths so long, so low in energy, that it becomes effectively undetectable by our instruments. This phenomenon further reinforces the idea of a horizon, not just of light travel time, but also of detectability. The light from some regions, though it may have had enough time to reach us, has been stretched beyond our capacity to observe it meaningfully, fading into a cosmic whisper. The deepest, most ancient edge we can truly observe is the cosmic microwave background, or CMB. This is not light from stars or galaxies, but rather the relic radiation from the universe's infancy, a faint uniform glow permeating all of space. It originated about 380,000 years after the Big Bang, a moment when the universe had cooled sufficiently for electrons and protons to combine and form neutral hydrogen atoms. Before this epoch, the universe was a dense, hot plasma, opaque to light, much like a thick fog. Photons were constantly scattering off free electrons, unable to travel far without colliding. But once the neutral atoms formed, the universe suddenly became transparent, allowing light to stream freely for the very first time. This first light, now redshifted to microwave wavelengths due to billions of years of cosmic expansion, provides us with a direct image of the universe when it was a mere fraction of its current age. It is, in essence, the visual boundary of our universe, the furthest back in time we can possibly see, a snapshot of the primordial cosmos. So, when we speak of the edge of the universe, we are not speaking of a physical barrier in space, but rather a profound temporal boundary, a visible horizon beyond which the light has not yet had time to reach us, or has been stretched beyond detection. This boundary is defined by the age of the cosmos and the speed of light, and it is a horizon that, in a deeply personal sense, surrounds each and every observer. The universe beyond this horizon remains an enigma, a realm that is, for now, forever beyond our direct observation, a silent, unseen expanse whose full nature continues to inspire our deepest scientific inquiries and our most tranquil contemplations. While the cosmic microwave background provides a profound visual boundary, a luminous echo from the universe's earliest moments, it is crucial to understand that this horizon does not, in fact, signify the physical edge of space itself. The universe in its entirety is almost certainly far grander and more expansive than the portion we can currently observe, or indeed will ever be able to observe directly. Our observable universe is merely the spherical region from which light has had sufficient time to reach us since the Big Bang. Beyond this sphere lies the unobservable universe, a vast expanse of cosmic structures, galaxies, and perhaps even entirely novel phenomena, whose light has simply not yet completed its journey across the ever-expanding cosmic distances to our location. It is akin to standing in the middle of a dense, ancient forest. You can only see as far as the trees allow, but you know that the forest continues far beyond your immediate line of sight. Scientists, through a combination of theoretical models and observational data, have come to believe that the true universe, the actual universe, extends far beyond our 13.8 billion light-year observational limit. One of the most compelling theories supporting this idea is cosmic inflation, a concept developed in the early 1980s by physicists such as Alan Guth. Inflation posits that in the merest fraction of a second immediately following the Big Bang, space underwent an incredibly rapid exponential expansion, stretching far faster than the speed of light itself. This was not the movement of objects through space, but the expansion of space itself, carrying all matter and energy along with it. This theory elegantly resolves several long-standing cosmological puzzles, including the apparent flatness and homogeneity of the universe on large scales. If inflation did indeed occur, it would have stretched any initial curvature of space to an almost perfectly flat state, much like inflating a small, wrinkled balloon to an enormous size makes its surface appear smooth and flat to an observer on it. This notion of a spatially flat universe is strongly supported by precise measurements of the cosmic microwave background, which reveal subtle temperature fluctuations that are entirely consistent with a flat geometry. In a spatially flat universe, parallel lines would remain parallel forever, and the angles of a triangle would sum precisely to 180 degrees, just as they do in Euclidean geometry. Such a universe, if infinite in extent, would have no spatial edges whatsoever. You could, in principle, travel in any direction indefinitely without ever encountering a boundary, a wall, or a point where space simply ends. This is a strikingly different image from the finite, bounded universe our everyday intuition might suggest. It implies a cosmos that, while having a temporal beginning, may well be boundless in its spatial dimension, stretching into an ultimate infinity, without any discernible center from which it expands. The Big Bang, therefore, was not an explosion in space, but rather the simultaneous emergence and expansion of space everywhere. The idea that the universe has no center is as important as the idea that it has no edge. When we observe distant galaxies rushing away from us, it is not because we occupy a privileged central position from which everything else is receding. Rather, every point in the universe experiences the same phenomenon. All other points appear to be moving away from it, much like dots on the surface of an inflating balloon. From the perspective of any dot, all other dots appear to recede, yet there is no single center on the surface of the balloon. Similarly, in our three-dimensional universe, every galaxy sees every other galaxy receding, and no specific location holds the distinction of being the cosmic center. This profound symmetry reinforces the absence of a spatial edge, as a universe without a center inherently lacks a reference point from which an edge could be defined. To contemplate a universe without a physical edge, a cosmos that simply extends without termination, can evoke a sense of serene awe. It suggests that our limited perception, shaped by the finite speed of light and the universe's own history, merely reveals a small, albeit magnificent, chapter of a much larger, perhaps endlessly unfolding, cosmic story. Our horizon is a boundary of knowledge, not of existence, a gentle reminder of the vastness that lies just beyond our current reach, inviting us to ponder the boundless possibilities that may reside in the unobservable depths of time and space. If space itself is without boundaries, stretching perhaps infinitely, then what does that imply for the future of our cosmic view? This profound thought leads us to another fascinating and somewhat mysterious aspect of our cosmos: dark energy. For decades, scientists expected the universe's expansion to gradually decelerate over cosmic time, a natural consequence of the gravitational pull exerted by all the matter within it. However, a startling discovery made in the late 1990s by two independent teams of astronomers revealed precisely the opposite. The expansion of the universe is not slowing down. It is, in fact, accelerating. This means that the rate at which galaxies recede from one another is increasing, a phenomenon attributed to a pervasive, enigmatic force that we have named dark energy. Dark energy, comprising approximately 68% of the universe's total energy matter content, acts as a kind of anti-gravitational force, subtly pushing space-time apart. Its precise nature remains one of the most profound unsolved mysteries in physics, but its observable effects are undeniable. This accelerating expansion profoundly impacts our understanding of the cosmic horizon. While the particle horizon defines the boundary of what we can currently see due to age, the accelerating expansion introduces another, more permanent boundary: the cosmic event horizon. The cosmic event horizon represents the ultimate limit of what we will ever be able to observe, even if we were to wait an infinite amount of time. Due to dark energy's relentless push, galaxies beyond a certain distance are already receding from us at speeds greater than the speed of light. It is important to clarify that these galaxies are not moving through space faster than light, which would violate Einstein's special relativity. Instead, the space between us and them is expanding so rapidly that their apparent recession velocity exceeds light speed. For light emitted from these increasingly distant regions, the journey towards us becomes a losing race. Even if a photon sets out in our direction, the space it needs to traverse stretches faster than the photon can cover it. It is as if the light is trying to swim upstream against an ever-strengthening current, destined never to reach the shore. This means that over immense cosmic timescales, as the acceleration continues, more and more galaxies will cross this cosmic event horizon, falling out of our observable universe forever. Their light, once visible, will become too redshifted, too faint, and too far behind the ever-stretching fabric of space to ever reach us. Imagine a future, billions upon billions of years from now, where the night sky, once ablaze with the myriad lights of countless galaxies, becomes a vast, empty darkness. Only the galaxies within our immediate gravitationally bound group, like the Andromeda Galaxy and the Milky Way, will remain visible, eventually merging into a single, colossal supergalaxy. All other galaxies, once dazzling points of light, will have receded beyond our cosmic event horizon, their light forever lost to our view, leaving behind a profound cosmic solitude. This profound cosmic solitude, though distant, offers a quiet reflection on the ephemeral nature of our current, vibrant cosmic view. Our existence coincides with a unique epoch in cosmic history, a fleeting window where the universe is both old enough for complex structures like galaxies and stars to have formed, and young enough for their light to still reach us across vast distances. Future civilizations, if they exist in this far-off, accelerating universe, would inhabit a cosmos drastically different from ours, a universe where the evidence of distant galaxies, and indeed the very notion of a Big Bang as a universal event, might be all but erased from their observable sky. They might even conclude that their local supergalaxy is the entire universe, unaware of the vast, unseen expanses that have long since slipped beyond their perception. This cosmic isolation, therefore, becomes a horizon not just of observation, but potentially of knowledge itself, shaping the understanding and philosophical outlook of any intelligence that might arise in those distant, lonely eons. It underscores the preciousness of our present cosmic moment, where the universe still largely reveals its grand history to us. The concept of a cosmic event horizon, where distant galaxies recede irrevocably beyond our observational grasp, invites us to contemplate the very nature of reality itself. If entire swathes of the cosmos are destined to become forever unobservable, does their existence somehow diminish for us? This is not merely a technical limitation of our instruments, but a fundamental feature of a universe governed by accelerating expansion. It means that the universe we perceive, the one we construct our models around, is always a partial picture, a snapshot from our unique vantage point in space and time. Our observable universe, then, is a bubble of information, constantly expanding but simultaneously losing content at its fringes as distant light struggles against the accelerating cosmic tide. This dynamic interplay between expansion and observation forces us to consider the limits of our knowledge, not just of physical space, but of the entire cosmic narrative. It paints a picture of a future where even the most advanced civilizations, equipped with technology far beyond our current imagining, might find themselves in an increasingly barren sky, unable to trace their cosmic origins or the grand evolutionary path of the universe, simply because the evidence has drifted beyond their reach, carried away by the relentless stretching of space. This quiet, inexorable fading of the cosmic tapestry is a profound thought, suggesting that our current epoch, with its rich, observable cosmos, is a unique, fleeting moment in the universe's long story, a period of maximum cosmic visibility. It is a precious, transient clarity before the encroaching veil of the unobservable deepens, a reminder of the universe's ceaseless transformation. Consider for a moment the fundamental constants that underpin our universe: the speed of light, the strength of gravity, the masses of elementary particles, and the charge of an electron. These values, meticulously measured and incorporated into our physical laws, define the very character of our reality, allowing stars to form, elements to fuse, and life to emerge. They are the fixed parameters of our cosmic home. But what if, beyond our cosmic event horizon, in those regions forever inaccessible to us, these constants were subtly, or even dramatically, different? While our current understanding of physics suggests a uniform set of laws throughout the observable universe, the possibility of variations in the unobservable regions remains a fascinating, albeit speculative, area of inquiry. Some theoretical frameworks, particularly those arising from inflationary cosmology and string theory, propose the existence of a multiverse, an ensemble of many universes, each potentially possessing its own unique set of physical laws and constants. This idea, often termed the cosmic landscape, suggests that our universe is just one of an immense number of possible universes, each born from a different outcome of the inflationary process, with its own distinct physical parameters, perhaps even a different number of spatial dimensions. The edge of our universe in this context then transforms from a mere temporal boundary of perception into a conceptual boundary separating one set of physical laws from another, a transition point into an entirely different realm of existence where the very rules of reality are reimagined. In such a grander cosmic tapestry, our universe would be but one thread, one bubble in a vast, ever-foaming sea of nascent realities. Each of these neighboring universes, if they exist, would be entirely causally disconnected from our own, meaning no information, no light, and no influence could ever pass between them. They would represent true beyonds, not in a spatial sense of being outside our universe, but as completely separate, self-contained space-time continua, each evolving according to its own intrinsic logic. This moves the concept of an edge from a boundary within our universe to a boundary between universes. It's a shift from thinking about the limits of our space to thinking about the limits of our reality, our particular set of physical laws. The edge then becomes a theoretical interface, a conceptual boundary where our known physics might cease to apply, giving way to entirely different rules of existence, perhaps even different fundamental dimensions or forms of matter we cannot yet conceive. This radical idea, while not directly testable with current technology, offers a profoundly expansive vision of the cosmos, suggesting that the nothingness beyond our observable horizon is not an empty void, but potentially an infinite array of other somethings, each with its own beginning, its own evolution, and perhaps its own intelligent observers, each a distinct cosmic narrative playing out in parallel. This perspective transforms our horizon from a barrier into a window, albeit a theoretical one, onto an unimaginable diversity of physical realities. It suggests that our quest to understand the edge of the universe is not just about mapping distances, but about grappling with the fundamental nature of existence itself, questioning whether our reality is singular or merely one of countless possibilities, each unfolding its own unique cosmic drama. Furthermore, some cutting-edge theories, like the holographic principle, add another layer of abstract complexity to this notion of a boundary. This principle, derived from studies of black holes and quantum gravity, suggests that all the information contained within a volume of space could be encoded on a two-dimensional surface enclosing that volume, much like a hologram. If this principle applies to the universe as a whole, then perhaps our three-dimensional reality is itself an emergent phenomenon, a projection from a deeper two-dimensional informational surface. In this view, the edge of the universe could be thought of not as a physical location, but as the very surface on which the fundamental data of our cosmos is written, a kind of cosmic canvas from which all appears to emerge. It is a boundary of information, a deeper layer of reality from which our familiar three-dimensional world arises, a subtle yet powerful reshaping of what we perceive as fundamental. This adds a profound, almost mystical dimension to our understanding of cosmic limits, suggesting that the universe's edge might be less about reaching a distant point and more about uncovering a deeper informational structure, an elegant code that defines our very existence. This contemplation of the unobservable, the potentially infinite, and the existence of other realities can be deeply calming. It places our individual existence within a context of immense scale and profound mystery, suggesting that our personal horizons, the limits of our own understanding and experience, are but reflections of the grander cosmic horizons. We are part of a universe that is constantly revealing itself, yet always holding secrets beyond our immediate grasp. This constant unfolding, this dynamic interplay between what we know and what we can only imagine, is a beautiful reminder of the endless journey of discovery that defines both science and our own conscious experience within the cosmos. To acknowledge the limits of our perception is not to admit defeat, but to embrace the boundless wonder of what lies beyond, fostering a peaceful sense of humility and interconnectedness with the grandest scales of existence. The edge, then, is not an ending, but an invitation to quiet contemplation of the infinite, a silent promise of deeper understanding yet to be unveiled, a gentle whisper from the unseen reaches of creation that reminds us of the endless possibilities woven into the very fabric of being. Our finite observations merely scratch the surface of an unbounded, magnificent cosmic ocean. And in that humbling realization, we find a tranquil beauty, a deep sense of belonging within the vast, intricate design of all that is. We are not just within the universe, we are a part of its continuous, mysterious unfolding, forever bound by its horizons, yet endlessly seeking what truly lies beyond. Human mind, in its remarkable capacity for abstraction and introspection, often seeks to draw maps and boundaries, to define and delineate the extent of its understanding. Yet the universe consistently challenges these innate tendencies, demonstrating that the most profound truths often reside in concepts that defy simple visualization or categorical partitioning. The edge of the universe, as a horizon in time, embodies this challenge perfectly. It is a boundary that expands with our knowledge, yet always keeps a step ahead, ensuring that a realm of the unknown persists. This perpetual state of discovery, this endless frontier, is not a source of frustration, but of enduring wonder. It signifies that the cosmos is not a solved puzzle, but a living, breathing mystery that continues to evolve, to unveil new layers of complexity and grandeur. And in that continuous unveiling, we find a mirror to our own growth, our own journey of learning and becoming. The universe, in its very structure, encourages us to remain open to the unexpected, to embrace the subtle shifts in our understanding, much like observing the slow, majestic dance of celestial bodies across the night sky. Each new observation, each refined theory, pushes our horizon a little further, revealing more of the universe's intricate beauty, while simultaneously reaffirming the immensity of what remains unobserved. This delicate balance, this dance between the known and the unknown, is what makes the study of the cosmos so deeply enriching, so profoundly calming to the inquisitive mind. It invites us to let go of the need for absolute finality and instead to find peace in the journey of perpetual exploration. The journey into understanding the universe's edge as a horizon of time and information rather than a physical barrier profoundly reshapes our perception of reality. It moves beyond the simple notion of space ending somewhere, pushing us towards an appreciation of the intricate interplay between light, time, and the very act of observation. This is a crucial distinction, for it means that the edge is not an inherent property of the universe's ultimate physical extent, but rather a dynamic boundary defined by our ability to perceive and gather data. We are, in essence, constantly situated at the center of our own observable bubble, a sphere whose radius is determined by how far light has traveled to reach us since the cosmic dawn. And this bubble, as we discussed, is not merely expanding. It is also losing content due to the accelerating expansion driven by dark energy, ensuring that some distant regions will forever remain beyond our sight. This constant push and pull creates a unique intellectual landscape. It highlights that our comprehension of the universe is fundamentally tied to the information that reaches us. Every photon carries a story, a message from a particular moment in cosmic history. When that message can no longer reach us due to the immense distances or the stretching of space-time, a part of the universe simply becomes unknowable to our direct senses. This isn't a flaw in our understanding, but a built-in feature of a relativistic, expanding cosmos. It's a gentle reminder of the universe's grand indifference to our desire for complete knowledge, yet also an invitation to find peace in the partial, the evolving, the always more to discover. The edge is, in this sense, a continuous challenge to our intellectual curiosity, a silent promise of endless inquiry. It is a boundary that recedes, yet always inspires, ensuring that the scientific endeavor remains vibrant and ever-expanding, much like the universe itself. The universe does not present itself as a completed book, but as an unfolding epic, where each new chapter pushes the narrative further into realms previously unimagined. This realization that the edge is a horizon intimately linked to our perspective deepens our connection to the cosmos. It implies that our individual now is a unique slice of space-time, and our observable universe is uniquely ours. While the laws of physics are universal, the specific manifestation of the universe as observed is local. This personal horizon means that every conscious being, wherever and whenever they exist in the vastness of the cosmos, experiences their own unique boundary of perception. There is no single objective edge that all beings would agree upon, because each observer is at the center of their own cosmic sphere. This is a profound departure from older, more static models of the universe, which often posited a fixed, universal boundary. Instead, we find ourselves in a dynamic, relativistic cosmos, where the concept of a limit is fluid, observer-dependent, and deeply intertwined with the passage of time itself. This is not a cause for disorientation, but for a calm appreciation of the universe's intricate design, where even the most fundamental aspects of reality are shaped by perspective. It encourages a sense of individual significance within the cosmic whole, recognizing that your unique point of observation is as valid and central as any other. It suggests that the quest for a definitive edge is perhaps a misplaced endeavor, as the very act of seeking defines the boundary itself. Rather, we are invited to embrace the provisional nature of our cosmic map, knowing that its contours are drawn by the very act of looking. The very act of seeking this edge, this ultimate boundary, becomes less about reaching a physical destination and more about pushing the limits of our conceptual frameworks. It is a constant refinement of our understanding of space-time, gravity, and the very nature of existence. This intellectual pursuit, while challenging, is also deeply meditative. It allows us to transcend our immediate terrestrial concerns and engage with questions of ultimate scope, finding a quiet satisfaction in the expansion of our mental horizons, even as the cosmic horizon remains just beyond our full grasp. The journey of scientific discovery, in this light, mirrors a spiritual quest, a continuous striving for deeper insight into the fundamental truths of being. The universe, in its boundless mystery, offers an endless canvas for such contemplation, inviting us to find serenity in the pursuit of knowledge itself. We are not just passive observers, we are active participants in this cosmic unfolding, our consciousness a tiny yet significant part of the universe's awareness of itself. And in that awareness, we find a tranquil resonance with the vastness that surrounds us, a gentle reminder of our intrinsic connection to the grand cosmic dance. Our minds, in their capacity to ponder such immensities, are themselves a testament to the universe's capacity for self-reflection. They are a delicate instrument through which the cosmos itself begins to understand its own intricate design and its own profound limits. Furthermore, the concept of a beyond our observable universe, a realm from which light has not yet reached us, or perhaps never will, is not an empty void, but a region of profound potential. It represents the unknown that fuels scientific inquiry, the vast expanse awaiting future discoveries, future theories, and perhaps even future forms of observation we cannot yet envision. This unobservable cosmos is not a place of existential dread, but a reservoir of possibility, a silent promise of further revelations. It allows us to imagine a universe that is not constrained by our current limitations, a universe that continues to unfold in ways that may forever surprise and inspire us. This open-endedness, this inherent incompleteness of our current cosmic map, is a source of serene excitement, a gentle nudge towards humility and continuous learning. It reminds us that our story and the story of the universe is far from over, always evolving, always offering new wonders to explore, even if only in the quiet chambers of our minds. The edge of the universe is thus not an ending, but a perpetual beginning, a constant invitation to wonder and to dream, fostering a deep sense of calm in the face of the truly immense. We are forever at the threshold of the unknown, and in that threshold, we find a peaceful, boundless expanse for our thoughts to wander and our understanding to grow. A gentle lullaby from the depths of time. This profound sense of a continuous, unfolding mystery is not a burden, but a liberation, freeing us from the need for absolute certainty and opening our minds to the endless dance of possibilities. It is a quiet testament to the universe's infinite capacity for self-revelation. This journey of conceptualizing the universe's non-physical edge, this horizon of time, ultimately brings us back to ourselves, reminding us that our own lives, in their fleeting beauty, are contained within a personal horizon of birth and death. And just as the cosmic horizon defines the limits of what we can see of the universe, our personal horizon defines the limits of our individual conscious experience. Yet within these boundaries, both grand and intimate, there is an infinite depth of meaning and connection. The atoms that compose us, the light that allows us to see, the very consciousness that contemplates these vast ideas, all are products of this same universe, woven into its ongoing story. To understand the cosmic edge as a temporal limit rather than a spatial wall is to embrace a deeper, more elegant truth about reality. It is to acknowledge that the universe is not a container with fixed sides, but an ever-evolving narrative, a grand, tranquil unfolding in which we are privileged participants. And in that participation, in that quiet contemplation, we can find a profound peace, a sense of belonging within the boundless mystery. The profound journey we have undertaken, contemplating the universe's edge not as a physical barrier, but as a dynamic horizon in time, brings us to a quiet realization about our own place within this cosmic narrative. This temporal boundary, constantly shifting and expanding, is not a sign of the universe's finitude, but rather a testament to its immense, perhaps boundless, extent, and our limited yet ever-growing capacity to perceive it. It reminds us that our understanding is always provisional, a work in progress, much like charting an endless ocean from a single, moving vessel. The unobservable universe, the realm beyond the reach of light that has had time to travel to us, is not empty space. It is teeming with events, with galaxies forming and evolving, with cosmic dramas unfolding, all just beyond the threshold of our direct perception. These distant events are real, they are happening, but their light, their information, is still on its arduous journey, or has been irrevocably stretched by the accelerating expansion of space, destined never to arrive. This subtle distinction between what exists and what is observable encourages a profound humility in our scientific endeavors, a recognition that the universe holds secrets that may forever whisper just beyond our grasp. It is a beautiful paradox. The more we discover, the more we become aware of the immensity that remains undiscovered, deepening our sense of wonder rather than diminishing it. This constant interplay between the known and the unknown fosters a tranquil curiosity, an invitation to embrace the mystery as an intrinsic part of existence itself. Our current epoch in this grand cosmic ballet appears to be a uniquely privileged moment. We exist at a time when the universe is old enough for complex structures like stars, planets, and even life to have emerged, yet young enough that the light from a vast number of these distant galaxies is still within our observable horizon. Future civilizations, if they arise in the far distant eons when dark energy has further stretched the fabric of space, may find themselves in a profoundly different cosmos. Their night sky could be largely empty, devoid of the myriad galaxies that currently populate our view, leaving them with an impoverished cosmological record. They might struggle to reconstruct the early universe, to understand the Big Bang, or even to conceive of the vast interconnected cosmic web that we observe today. This thought, while tinged with a gentle melancholy for the future, underscores the preciousness of our present cosmic vista. It is a reminder to cherish this fleeting window of clarity, to absorb and contemplate the universe's grandeur while it is still so richly displayed before us. The light reaching us now is a relic, a whisper from a bygone era, carrying tales of cosmic evolution that will eventually fade into an ultimate, unobservable silence for those who come after. This passing of information, this slow retreat of the cosmic past, is a poignant illustration of time's relentless flow, shaping not just the universe, but our very ability to witness its story. It teaches us that our perception of the cosmos is a temporary gift, a unique perspective from a particular moment in the universe's grand unfolding. The tools of theoretical physics, armed with mathematics and sophisticated models, allow us to peer beyond this observational veil, to infer the existence and properties of the unobservable universe. We extrapolate from the laws we observe, from the subtle patterns in the cosmic microwave background, and from the dynamics of galaxy clusters to construct a coherent picture of a cosmos that extends far beyond what light can currently show us. These models, such as those describing cosmic inflation or the large-scale structure of the universe, are not mere speculation. They are rigorously tested against all available data, providing the most consistent and elegant explanations for the universe's observed features. They are our intellectual instruments for traversing the unobservable, for painting a picture of a universe that is truly without spatial bounds. A universe where the Big Bang occurred everywhere simultaneously, without a central point or an external outside into which it could expand. This reliance on inference and mathematical beauty, rather than direct observation for the furthest reaches, is a sophisticated form of seeing, a seeing with the mind, guided by logic and consistency. It is a testament to the power of human intellect to grasp concepts that lie beyond the direct reach of our senses, fostering a deep sense of intellectual satisfaction and a tranquil confidence in the predictive power of science. This process of building models to describe the unseen is, in itself, a form of cosmic poetry, where equations become the language of ultimate truth, allowing us to conceptualize the vastness that remains forever just out of sensory reach. Ultimately, understanding brings us to a deeply personal reflection. Our own lives are defined by a personal horizon, a span of time from birth to eventual rest. Within this span, we gather information, form memories, and construct our own understanding of the world. Just as the cosmic horizon limits our view of the universe's totality, our personal horizon limits our individual conscious experience. Yet within these defined boundaries, whether cosmic or personal, lies an infinite depth of meaning, connection, and potential for wonder. The very atoms that constitute our bodies were forged in the hearts of ancient stars, scattered across the cosmos, and eventually gathered to form our planet and ourselves. The light that allows us to see, to learn, to contemplate these vast ideas, is a continuous thread connecting us to the universe's grand narrative. Our consciousness, in its remarkable ability to ponder these immensities and to find beauty in the unknown, is itself a product of this cosmic unfolding, a fleeting yet profound expression of the universe becoming aware of itself. In this tranquil awareness of our interconnectedness, in this acceptance of horizons both vast and intimate, we can find a profound sense of peace. The universe, in its boundless, edgeless expanse, does not demand a final answer, but invites continuous contemplation, a gentle, unending journey of discovery. And in that journey, we can allow our minds to drift, knowing that even as we rest, the cosmos continues its majestic, silent dance, holding infinite wonders both seen and unseen, forever just beyond the horizon of our present moment. This sense of belonging to an eternal unfolding mystery, even in its partial revelation, is the true calm that the study of the universe offers, a silent lullaby woven from the fabric of space-time itself. Universes. May these deep thoughts about the universe's edge, not as a boundary in space, but as a profound horizon in time, carry you into a world of tranquil sleep. As we drift through the cosmic night, remember that our observable universe is a precious, fleeting glimpse into an immense and perhaps boundless reality, a tapestry woven from light and time. The unseen depths, the realms beyond our current perception, are not empty voids, but rather realms of unending potential and mystery, a silent promise of discoveries yet to unfold. Consider the gentle rhythm of the cosmos, its ceaseless expansion, and the patient journey of ancient light. In this grand, evolving narrative, our own existence, our own brief moment of consciousness, is intricately connected to the stars and the very fabric of space-time. We are, in a profound sense, the universe experiencing itself, contemplating its own magnificent, edgeless expanse. May you fall asleep with this feeling of serene wonder, embracing the beautiful paradox of a cosmos that is both knowable and eternally mysterious. Rest in the knowledge that you are a part of this amazing dance, a conscious flicker within the infinite unfolding. Good night. The question of what the universe is expanding into is one that often arises, conjuring images of a grand cosmic bubble stretching outward into some larger, empty void. Yet the reality, as revealed by the profound insights of modern cosmology, is far more subtle and, in its own way, even more astonishing. When we speak of the universe expanding, we are not talking about galaxies rushing through a pre-existing static space, as if they were shrapnel from an explosion. Instead, it is space itself that is expanding, growing and stretching, carrying the galaxies along with it. This distinction is crucial, for it means there is no edge to this expansion and no outside for the universe to fill. The universe, in this cosmological sense, is everything, and its expansion is the continuous creation of more space within itself. To truly grasp this, let us return to the familiar analogy of the surface of a balloon being inflated. Imagine tiny celestial bodies, like galaxies, drawn upon its two-dimensional surface. As the balloon expands, every drawn galaxy moves away from every other drawn galaxy. There is no central point on the surface from which they are all fleeing. Each galaxy observes all others receding from it, a uniform exodus driven not by their own motion across the surface, but by the stretching of the rubber itself. Now, this analogy is imperfect, as it represents a two-dimensional surface expanding into a third dimension. Our universe, however, is thought to be three-dimensional space, expanding into nothing external. It is the very fabric of our three-dimensional space that is stretching, not through some higher dimension, but intrinsically from within. This means that new space is simply coming into existence between gravitationally unbound objects, gently pushing them further apart. This profound understanding began to solidify in the 1920s, largely through the groundbreaking work of astronomers like Edwin Hubble. Observing distant galaxies, Hubble discovered a remarkable pattern. The farther away a galaxy was, the faster it appeared to recede from us. This relationship, now known as Hubble's law, was a pivotal moment in cosmology. The primary evidence for this recession comes from the phenomenon of redshift. As light from these distant celestial islands travels across the vast cosmic distances, the space it traverses expands. This stretching of space literally elongates the light waves themselves, increasing their wavelength and shifting them towards the red end of the electromagnetic spectrum, much like a siren's pitch drops as it moves away. This is not merely a Doppler effect caused by galaxies flying through space, but rather a direct consequence of the stretching of space itself. Further confirmation of this pervasive expansion comes from the cosmic microwave background radiation, the faint echo of the Big Bang, which permeates all of space and exhibits a uniform cooling over time, consistent with a universe that is steadily growing larger. One might then reasonably wonder, if everything is moving away from everything else, does that imply a center to this expansion, a point from which everything originated? Here again, our everyday intuition, honed by experiences within a static framework, can be profoundly misleading. The expansion of the universe has no identifiable center. Just as every point on the surface of an inflating balloon moves away from every other point without any single point being the center of the expansion, so too does every region of our universe experience this stretching of space. No matter where an observer is situated in the cosmos, they would witness the same universal outward flow, with distant galaxies receding from their vantage point in every direction. This concept is fundamental to the cosmological principle, which posits that the universe is homogeneous and isotropic on large scales, meaning it looks roughly the same everywhere and in every direction. Such a universe, though potentially finite, has no edges and no privileged center, much like the surface of the Earth is finite but boundless. This dynamic view of space is deeply rooted in Albert Einstein's revolutionary theory of general relativity, which was published in 1915. Einstein's equations revealed that space and time are not separate, static entities, but are interwoven into a single, flexible fabric called spacetime. This fabric is not a passive stage where cosmic events unfold. Rather, it is an active participant, capable of being warped and curved by the presence of mass and energy. The expansion of the universe is precisely this: a change in the geometry of space-time itself. It is not an event happening within space, but rather the evolution of space itself. It is the very structure of the cosmos that is changing, growing, weaving new distances between us and the most remote celestial islands. This means that when we look out into the night sky, we are not just observing objects in space, but witnessing the profound evolution of space itself, a silent, ceaseless unfolding that reshapes reality on the grandest scales. What then is driving this relentless expansion? For a long time, scientists assumed that the gravitational pull of all the matter in the universe would gradually slow down this expansion. However, in the late 1990s, astronomers made a startling discovery. The expansion of the universe is not slowing down, it is accelerating. Something is actively pushing space apart, causing it to stretch faster and faster. This mysterious force, or property of space, has been dubbed dark energy. While its exact nature remains one of the greatest puzzles in modern physics, current cosmological models suggest that dark energy makes up about 68% of the total energy density of the universe. It is a pervasive, repulsive force inherent to space itself, essentially causing more space to generate more dark energy, leading to an ever-increasing rate of expansion. This suggests that the void is not merely inert, but actively participating in the cosmic drama, a subtle yet powerful force shaping the destiny of everything. It is important to remember that this cosmic expansion is a large-scale phenomenon. We do not observe our bodies, our homes, our planet, or even our solar system stretching. This is because local gravitational forces and other fundamental interactions are overwhelmingly stronger than the expansive pull of dark energy on these smaller scales. Our galaxy, the Milky Way, and its immediate neighbors in the local group are gravitationally bound, meaning they are moving towards each other or orbiting a common center, unaffected by the overall expansion of the universe. The expansion only becomes evident when we observe structures that are not gravitationally bound to each other, such as distant galaxy clusters, where the stretching of space between them truly dominates their relative motion. Consider for a moment what this implies for your own existence, nestled within this vast and dynamic cosmos. You are a part of this expanding tapestry, a collection of atoms held together by forces that resist this universal stretching on local scales. While distant galaxies drift apart, your own being remains cohesive, a testament to the strength of the fundamental forces that govern matter. Yet the very space around you, in a subtle and immeasurable way, is also part of this grand unfolding. It is a profound reminder that our understanding of reality is constantly evolving, challenging our most basic assumptions about the nature of existence. What does it mean for our place in the cosmos to be part of something that is not just immense, but actively growing, moment by moment, without a true boundary or an external end? It evokes a sense of deep wonder, a quiet contemplation on the dynamic nature of everything we perceive and our fleeting yet significant presence within it. The universe is not merely expanding, it is an active, living entity, forever reshaping its own boundaries, and in doing so, it continually redefines our perception of its profound and infinite mystery. We have reflected upon the astonishing fact that the universe is not expanding into something, but rather that space itself is stretching, creating new distances between galaxies. This concept, so fundamental to our modern understanding, often challenges our intuitive grasp of reality. We are accustomed to thinking of expansion in terms of objects moving through a pre-existing container. But imagine, if you will, not a container, but the very canvas upon which all is painted, slowly, invisibly growing larger. This growth is a property of the cosmic fabric, the very geometry of space-time, and it means that for every unit of distance, more distance is being added. It is a continuous, gentle unfolding, an intrinsic property of the cosmos that does not require an external void to receive it. The universe in its entirety is the space, and its expansion is merely the increase of its own internal distances, a subtle yet profound act of self-generation that permeates every corner of its vastness. This is not a dramatic outward surge, but a pervasive, quiet stretching that happens everywhere at once, unseen by the casual eye, yet measurable by the most sensitive instruments. One of the deepest questions arising from this expansion concerns the ultimate geometry of our universe. Is it open, closed, or flat? These terms describe the overall curvature of space on the grandest scales, and each carries profound implications for its past, present, and future, as well as for the very nature of its boundlessness. A closed universe, much like the surface of a sphere, would be finite in extent, but boundless, allowing a journey in one direction to eventually return to the starting point. Its destiny, under the influence of gravity, would likely be a big crunch, where expansion reverses and all matter collapses back in on itself. In contrast, an open universe, akin to a saddle shape, would extend infinitely and expand forever, its curvature causing parallel lines to eventually diverge. A flat universe, conceptually like a vast endless plane, also expands indefinitely, though at a decelerating rate, if not for the influence of dark energy. Here, parallel lines would always remain parallel. For decades, cosmologists have meticulously analyzed data to discern which of these geometries best describes our cosmos. The most compelling evidence comes from precise measurements of the cosmic microwave background radiation, the ancient light from the early universe. These observations, particularly those from missions like the Wilkinson Microwave Anisotropy Probe and the Planck satellite, reveal subtle temperature fluctuations in this background radiation. The angular size of these fluctuations acts as a cosmic ruler. If the universe were closed, these hot spots would appear larger than they are. If it were open, they would seem smaller. What we observe points overwhelmingly to a flat geometry. This means that parallel lines, if extended indefinitely, would remain parallel, and the sum of angles in a large triangle would precisely equal 180 degrees, just as in Euclidean geometry. This finding aligns beautifully with the theory of cosmic inflation, a period of extremely rapid expansion just fractions of a second after the Big Bang. Inflationary models naturally predict that the universe should be extraordinarily flat, smoothing out any initial curvature. It is as if a tiny, wrinkled region of space-time was stretched so dramatically that it became virtually flat on observable scales, much like a small bump on a balloon becomes imperceptible when the balloon is fully inflated. This elegant connection between the geometry of the universe and its earliest moments provides a profound anchor for our understanding of cosmic evolution. Yet, even if the universe is spatially infinite, our perception of it is limited. We speak of the observable universe, which is the spherical region of space from which light has had time to reach us since the Big Bang. This is not a boundary of the universe itself, but a boundary of our current observation. Imagine yourself at the center of a vast, ever-expanding sphere of light. Everything within that sphere is what you can potentially see. Beyond it lies the unobservable universe, regions from which light simply has not had enough time to travel to us, even at the incredible speed of light over the 13.8 billion years of cosmic history. This limit defines our cosmic horizon, a boundary of information rather than of physical space. It recedes from us as time progresses and light from ever more distant regions finally arrives. This means that the universe we perceive is a constantly growing sphere, but it is a sphere centered on us, the observer, and every other observer in the cosmos has their own unique observable universe, their own cosmic horizon stretching out around them. This realization can be both humbling and exhilarating. We are confined to our own cosmic window, able to glimpse only a fraction of what might truly exist. Yet, within this observable realm, there is an astounding immensity, a symphony of galaxies and structures that continues to inspire awe. To ponder the unobservable, the vast regions forever beyond our sight, is to acknowledge the profound mystery that still envelops us. It suggests that the true scale of existence might be far grander than our most ambitious measurements or theories can currently capture, reminding us of the endless depths of discovery that lie ahead, or perhaps forever out of reach, a quiet invitation to contemplate the boundless nature of reality itself. It reminds us that even with all our technological marvels, the universe holds secrets that may forever whisper just beyond our grasp, inviting a deep, tranquil contemplation of our place within its grand, expanding story. We have reflected upon the vastness of the observable universe and the profound mystery of the regions beyond our cosmic horizon. This boundary, defined by how far light has traveled to us over 13.8 billion years, reminds us that our perception is inherently limited, a fleeting snapshot of an ever-growing cosmic tapestry. Yet, even within this observable sphere, a deeper, more enigmatic force is at play, one that not only orchestrates the stretching of space, but accelerates its very expansion. This mysterious entity, which we call dark energy, represents perhaps the most profound puzzle in modern cosmology, shaping the ultimate destiny of everything we know. Dark energy is not a form of matter or radiation in the conventional sense. It does not clump together or interact with light. Instead, it appears to be an intrinsic property of space-time itself, a pervasive pressure that gently pushes the cosmos apart, causing the expansion to speed up rather than slow down under the influence of gravity. The discovery of this accelerated expansion in the late 1990s by independent teams of astronomers, including Saul Perlmutter, Adam Rees, and Brian Schmidt, came as a profound shock to the scientific community. They were studying distant supernovae, using them as standard candles to measure cosmic distances and the rate of expansion. The unexpected result was clear. The universe's expansion was not decelerating, as gravity would suggest, but was instead gaining momentum. This accelerating force aligns with a concept first introduced by Albert Einstein into his equations of general relativity: the cosmological constant. Initially, Einstein added this term to allow for a static universe, a notion he later famously called his biggest blunder after Hubble confirmed cosmic expansion. However, the cosmological constant, representing the energy density of empty space, now seems to be the most viable explanation for dark energy. It suggests that the vacuum of space is not truly empty, but possesses an inherent energy that exerts a repulsive gravitational effect. As space expands, more vacuum comes into existence, and thus more dark energy, leading to a self-reinforcing acceleration of the cosmic stretch. It is a subtle, constant hum of energy woven into the very fabric of existence, driving the universe towards an ever more diffuse future. The implications of this relentless acceleration are profound for the long-term fate of the universe. If dark energy continues to dominate, the most widely accepted scenario predicts a heat death of the universe. This is not a sudden, dramatic apocalypse, but a gradual, quiet descent into ultimate cold and emptiness. As space continues to expand and accelerate, galaxies that are not gravitationally bound to our own local group will recede beyond our cosmic horizon at an ever-increasing rate. Their light will become so stretched and faint, so redshifted, that it will eventually fade into an undetectable whisper. Over trillions of years, even the stars within galaxies will exhaust their fuel, collapsing into white dwarfs, neutron stars, and black holes. These remnants will eventually cool and evaporate, leaving behind a cosmos of ever-increasing emptiness, where the distances between any remaining particles become astronomically vast. Imagine a future far beyond human comprehension, where civilizations might gaze out into a night sky that is almost entirely dark, devoid of the luminous galaxies we see today. They would be isolated, trapped within their own gravitationally bound cluster, with no discernible evidence of the grand cosmic tapestry that once connected us all. The universe in their epoch would appear profoundly different, a testament to the ephemeral nature of our current, vibrant cosmic view. This cosmic isolation, though occurring on timescales that render it almost abstract, offers a profound reflection on the fleeting nature of our present cosmic window. We exist in a unique moment, a brief golden age where the universe is rich with observable structure, where light from billions of galaxies still reaches our telescopes. Our consciousness, our very ability to ask these questions about cosmic expansion and its destiny, exists within this precious, temporary epoch. To consider this deep future is to realize that our present view is a gift, a rare opportunity to witness a universe still teeming with light and wonder, before the slow, inexorable stretching of space potentially carries much of its grandeur beyond our reach forever. The cosmic journey we have undertaken, exploring the universe's expansion not into a void, but as the stretching of space itself, and contemplating its distant, quiet end, naturally leads us to reflect upon its dramatic beginning. For it is in the very first moments, just after the Big Bang, that the seeds of this expansion were sown, and the stage was set for the cosmos we inhabit. Our current understanding points to a period of astonishingly rapid growth known as cosmic inflation, a theoretical framework developed to resolve several perplexing questions about the universe's initial conditions. Imagine, if you will, the universe as an infinitesimally small, incredibly dense point, brimming with unfathomable energy. Then, in an instant, a burst of exponential expansion occurred. This was not the gradual stretching we observe today, but a superluminal acceleration where space itself expanded faster than the speed of light. Such a concept, while challenging to visualize, is permitted by the laws of physics, as it is space, not matter moving through space, that undergoes this rapid inflation. This period, lasting for only a tiny fraction of a second, just 100 trillionth of a second, effectively smoothed out any initial irregularities, making the universe remarkably uniform and flat on large scales, much like inflating a tiny crumpled piece of paper to an immense size would make its surface appear perfectly smooth and flat. This elegant solution addresses what cosmologists refer to as the flatness problem and the horizon problem, explaining why distant regions of the universe, too far apart to have ever interacted since the Big Bang, nonetheless exhibit such similar temperatures in the cosmic microwave background. This theory of cosmic inflation, first proposed by Alan Guth in 1980, is more than a clever mathematical trick. It is supported by the subtle patterns observed in the cosmic microwave background. The minute variations in temperature within this ancient radiation, meticulously mapped by instruments like the Planck satellite, are precisely what inflation predicts. Quantum fluctuations in the very early universe, stretched to cosmic scales by the rapid expansion, forming the primordial seeds for the vast structures of galaxies and galaxy clusters we see today. It is a profound thought that the largest structures in the universe, the colossal webs of galaxies stretching across millions of light years, may owe their existence to quantum jitters on the smallest conceivable scales, magnified into cosmic reality. This transformation of quantum uncertainty into cosmic architecture offers a truly humbling perspective on the interconnectedness of all scales of existence. But the theory of inflation holds an even more radical implication for our understanding of cosmic expansion, the possibility of a multiverse. In some inflationary models, the process of inflation might not have ended uniformly everywhere. Instead, it could be an eternal phenomenon, continuing indefinitely in vast regions of a larger meta-universe, while in localized pockets like our own, inflation ceases, giving birth to separate, bubble universes. Each of these bubbles would then expand and evolve according to its own initial conditions and fundamental physical laws. Our universe in this grander cosmic landscape would simply be one bubble among an infinite or near-infinite ensemble of other universes, each perhaps vastly different from our own, with varying constants, different types of particles, or even entirely distinct dimensions. This concept profoundly shifts our perspective on what the universe is expanding into. It suggests that our universe is not expanding into an external void of nothingness, but rather into a continually inflating metaspace that is simultaneously giving rise to countless other universes. It is as if the cosmic expansion we observe is a local manifestation of a much larger ongoing process of universal generation. This eternal inflation theory implies that the universe, in its broadest sense, is an ever-birthing entity, an endless factory of realities, each unfolding according to its own unique cosmic narrative. Such a vast and intricate tapestry of existence, where our universe is but one thread, invites a deep sense of philosophical contemplation. Are the fundamental laws and constants of our universe merely arbitrary selections from an infinite array of possibilities, fine-tuned by chance for the emergence of life and consciousness? Or is there a deeper principle that favors universes like ours? While these questions remain largely in the realm of theoretical physics and philosophy, the very possibility of a multiverse challenges our anthropocentric view, urging us to consider our place not just within one universe, but within an unimaginably diverse cosmic ensemble. It offers a tranquil yet profound shift in perspective, transforming our sense of isolation into a feeling of belonging within an infinitely grander, perpetually expanding cosmic story, where your conscious awareness is a fleeting, precious glimpse into one tiny yet magnificent corner of reality's boundless unfolding. We have ventured into the realm of the multiverse, where our universe might be but one of countless cosmic bubbles, each with its own laws, all expanding within a grander, eternally inflating metaspace. This profound revelation naturally leads us to a deeper inquiry. What is this space that expands, that stretches and grows? What is its most fundamental nature beneath the familiar three dimensions we perceive, interwoven with time into space-time? Our most successful theories of the cosmos, general relativity and quantum mechanics, describe reality with breathtaking precision, yet they speak in different languages, particularly when it comes to the very fabric of existence at its most extreme scales. General relativity paints space-time as a smooth, continuous, and dynamic sheet, bending and flowing under the influence of matter and energy. Quantum mechanics, on the other hand, reveals a universe built from discrete, quantized packets of energy and information. When we attempt to merge these two pillars of physics into a single, unified theory of quantum gravity, the very notion of continuous space-time begins to dissolve, hinting that space itself might not be fundamental, but rather an emergent phenomenon, much like the smooth surface of an ocean emerges from countless individual water molecules. This is the frontier of theoretical physics, where our most cherished assumptions about reality are gently but firmly questioned, pushing the boundaries of our cosmic understanding into realms of profound abstraction. Consider for a moment the profound implications of such a perspective. If space is not an infinitely divisible continuum, but rather composed of discrete, irreducible units, like tiny fundamental grains, then its expansion takes on a profoundly different character. It would not be the stretching of an already smooth canvas, but rather the continuous addition of these elementary spatial atoms. One prominent contender for a theory of quantum gravity is loop quantum gravity, a framework that proposes that space-time is quantized, woven from an intricate network of minuscule loops, far smaller than anything we can currently detect, existing at the Planck scale, which is roughly 10 to the power of minus 35 meters. In this view, space is fundamentally granular, a kind of cosmic weave, not unlike a digital image appearing smooth from a distance, but revealing individual pixels upon closer inspection. The expansion of the universe, then, could be interpreted as the growth of this network, the generation of more fundamental loops, effectively adding new pixels to the cosmic image. This is a subtle, yet powerful reinterpretation of expansion, suggesting that the universe is not pushing into anything external, but rather generating more of its own intrinsic components. It is a quiet, ceaseless act of self-construction, a continuous unfolding of reality from its most elemental constituents. This perspective offers a profound sense of self-sufficiency for the universe, an entity that expands by creating more of its own substance, rather than merely occupying more of an external container. It transforms the perceived emptiness into a dynamic, generative medium, a quiet engine of cosmic creativity. Another theoretical avenue, string theory, offers a different, yet equally radical vision of space-time's origins. In this framework, the fundamental constituents of the universe are not point-like particles, but rather tiny, vibrating one-dimensional strings. The different vibrations of these strings give rise to all the various particles and forces we observe. Crucially, string theory often requires the existence of extra spatial dimensions, typically 10 or 11 in total, which are curled up or compactified into incredibly small scales, rendering them imperceptible to us in our everyday experience. From this perspective, our familiar four-dimensional space-time, including its expansion, could be an emergent phenomenon, a projection or a lower-dimensional manifestation of these higher-dimensional dynamics. The expansion of our three spatial dimensions might then be linked to the unfolding or stretching of these hidden dimensions, or perhaps the way these fundamental strings interact and organize themselves to create the illusion of a continuous, expanding space. This is a concept that echoes the holographic principle we sometimes discuss, where a three-dimensional reality might be encoded on a two-dimensional boundary, implying that our perceived reality is a kind of projection from a deeper, more complex substrate. In this view, the universe isn't expanding into anything in the conventional sense, but rather its dimensionality is being revealed or further manifested from an underlying higher dimensional reality. A silent, elegant dance of fundamental strings, creating the vastness we observe, a symphony of vibrations. The very fabric of our perceived reality, then, could be a mere shadow cast by these unseen, intricate dances. These are not mere philosophical musings, but active areas of scientific research, seeking to bridge the chasm between the very large and the very small to understand the universe at its most foundational level. The immense challenge lies in reconciling the smooth, macroscopic geometry of general relativity, which describes gravity as the curvature of space-time, with the turbulent probabilistic nature of quantum mechanics, which governs particles at the Planck scale. This quest is to uncover the ultimate building blocks of reality and to comprehend precisely how they give rise to the space-time we inhabit and the expansion we measure. These theories push the boundaries of our imagination, suggesting that empty space is anything but empty. It is a vibrant quantum foam, constantly bubbling with virtual particles and latent energy, a dynamic substrate from which everything, including the very expansion itself, arises. This fundamental reevaluation of the vacuum of space is central to understanding what the universe is truly expanding from and how it continues to grow. While still speculative, these theories invite us to consider that the nature of space and time, the very stage upon which our lives unfold, might be far more ephemeral and dynamic than we instinctively believe. Our everyday experience of a solid, unchanging ground beneath our feet and a steady flow of time is a macroscopic approximation, a simplification of a far more intricate and fluctuating quantum reality. The expansion of the universe, when viewed through the lens of quantum gravity, becomes a question not just of scale, but of fundamental ontology. Is the universe expanding by adding more fundamental units of space, or by revealing more of its inherent, higher-dimensional structure? This shift in perspective from space as an empty container to space as a dynamic, emergent entity is a cornerstone of our evolving cosmic narrative, prompting us to rethink the very definition of nothingness and its profound active role in the cosmos. And when we consider this, it shifts our perspective on ourselves in a subtle yet profound way. You, listening now, are a complex pattern of particles and fields intricately woven into the fabric of this expanding cosmos. Your very existence, your thoughts, your consciousness are intimately connected to the fundamental laws that govern the universe's origin and its ongoing evolution. If space is emergent, if reality is granular at its core, then your own sense of being, of having a fixed location in an expanding cosmos, is a beautiful, intricate dance of these fundamental constituents. It is a quiet invitation to ponder that perhaps your own personal space, the space of your immediate surroundings, is also, in its own way, a localized manifestation of this grand cosmic stretching. It is a space that feels solid and stable, yet is subtly influenced by the very same expansion that separates galaxies. This deep connection reminds us that we are not passive observers of the universe, but active participants, our very being echoing the grand processes of creation and expansion. This realization can bring a deep sense of calm, an understanding that even in our smallest moments, we are part of something infinitely vast and perpetually unfolding, a silent, graceful dance of existence. We have pondered the profound implications of space itself being an emergent, perhaps even granular phenomenon, rather than an inert, continuous backdrop. This leads us to question the very nature of what we colloquially call empty space, or the vacuum. Our intuition often perceives a void as simply the absence of anything at all. No matter, no light, no energy. Yet, at the most fundamental levels of reality, as described by quantum field theory, such absolute emptiness does not exist. The quantum vacuum is, in fact, a vibrant, restless sea of activity, a dynamic medium constantly teeming with fleeting energy fluctuations. Imagine, if you will, not a serene, still pond, but a deep, dark ocean, where even in its calmest depths, countless bubbles spontaneously form and vanish in a ceaseless dance. These bubbles are analogous to what physicists call virtual particles, pairs of particles and antiparticles that momentarily pop into existence from the vacuum's inherent energy, only to almost immediately annihilate each other, returning their borrowed energy to the quantum field. This phenomenon is not merely theoretical speculation, its effects are measurable. The Casimir effect, for instance, demonstrates that two uncharged parallel metal plates placed extremely close together in a vacuum will experience a tiny attractive force. This force arises because the fluctuating quantum fields between the plates are constrained, allowing fewer virtual particles to exist there compared to the unconstrained space outside, creating an imbalance in vacuum pressure that gently pushes the plates together. This extraordinary observation confirms that even in the deepest void, there is a tangible, energetic presence. This inherent energy of the quantum vacuum is, in essence, the leading candidate for the mysterious dark energy that drives the accelerating expansion of our universe. It suggests that space itself possesses an intrinsic energy density, a pervasive pressure that acts as a form of anti-gravity, gently pushing galaxies further apart. As the universe expands, more space comes into being, and with it, more of this vacuum energy. This creates a self-sustaining cycle. The expansion generates more dark energy, which in turn drives further, faster expansion. It is a cosmic engine powered by the very fabric of nothingness, continuously generating more of itself. This is why the universe is not expanding into something external. It is expanding by creating more of itself from within, powered by the latent energy of the quantum vacuum. The implications of this vacuum energy are not limited to the distant future of the cosmos. They extend back to its very beginning. During the period of cosmic inflation, it is believed that a much more potent form of vacuum energy temporarily dominated the universe, driving its hyper-rapid exponential expansion. This primordial vacuum energy stretched the nascent cosmos to unimaginable scales, smoothing out any initial irregularities and setting the stage for the homogeneous, flat universe we observe today. Even after inflation ended, a residual, much weaker form of this vacuum energy persisted, which we now identify as the dark energy accelerating the universe's current expansion. Thus, the expansion we witness today is a direct descendant of the explosive growth that shaped the very earliest moments of reality. This understanding profoundly reshapes our concept of the cosmic void. It is no longer a passive emptiness waiting to be filled, but an active, energetic medium, a dynamic source of creation and propulsion. The universe's expansion is not a movement through a pre-existing container, but rather the continuous generation of new space, new distances, woven into the fabric of reality by this ceaseless quantum activity. It is a universe that is not merely growing larger, but perpetually renewing and creating its own dimensions from within. Consider this profound dance of creation and expansion, this subtle hum of energy that underlies everything. Your own awareness, your very existence, unfolds within this dynamic, self-generating cosmos. The space around you, seemingly static and familiar, is a part of this grand, ongoing process, a localized manifestation of the universe's intrinsic energy. Peace, a quiet understanding that you are not separate from the vast cosmic unfolding, but intimately connected to its most fundamental rhythms. It invites a contemplative awareness that even in the stillness of your quiet surroundings, the universe is actively expanding, creating more of its wondrous self, and in that silent, majestic process, you're an integral, conscious participant. This cosmic embrace offers a tranquil reassurance, a gentle reminder that your place in the universe is not merely observed, but deeply woven into its very essence, a fleeting yet eternal pattern in the boundless dance of existence. We have just considered the profound implications of the quantum vacuum, a restless sea of energy that may well be the dark energy driving the accelerated expansion of our universe. This invisible force, inherent to space itself, is gently but relentlessly pushing all gravitationally unbound structures further and further apart. This acceleration means something quite remarkable for our cosmic future, and indeed for our present perception. It implies the existence of a cosmic event horizon, a boundary far more profound than the mere edge of our observable universe. To truly grasp this concept, let us consider a more detailed distinction. The particle horizon defines the limit of what we can currently observe. It is the maximum distance from which light, emitted since the Big Bang, has had sufficient time to reach us. This horizon is ever expanding, as each passing moment allows light from slightly more distant regions to finally arrive at our telescopes, gradually revealing new celestial wonders. However, the cosmic event horizon presents a different, more absolute kind of limit, one dictated by the accelerating nature of the universe's expansion. Due to dark energy's persistent push, there are galaxies so distant that light emitted from them today, even if traveling at the ultimate speed limit of the cosmos, will never reach us. The space between us and those galaxies is expanding so rapidly and will continue to accelerate its stretching that any light signal attempting to bridge the gap will be forever carried away by the expanding fabric of space-time, unable to ever reach us. This is a concept that challenges our everyday understanding of distance and speed. We are accustomed to thinking of objects moving through space and thus being constrained by the cosmic speed limit of light. Yet here, it is space itself that is expanding. Imagine 2 points on a stretching rubber sheet. The points themselves are not moving on the sheet, but the sheet itself is growing, increasing the distance between them. If the sheet stretches fast enough, two very distant points can effectively recede from each other at a rate greater than the speed of light, not because they are moving through space faster than light, but because new space is being created between them. This is precisely what happens in the universe on cosmological scales. Distant galaxies appear to recede from us at speeds greater than the speed of light, not violating Einstein's theory of special relativity, because it is the expansion of space, not the motion of objects through space, that is responsible. The rate of this cosmic stretching is quantified by the Hubble parameter, often referred to as the Hubble constant, though it is not truly constant but changes over cosmological time. Its value reflects how quickly the universe is expanding at any given moment. Current measurements, primarily from observations of the cosmic microwave background and distant supernovae, suggest a value that indicates the universe is expanding by about 70 kilometers per second for every 3.26 million light-years of distance. However, a fascinating puzzle in modern cosmology, known as the Hubble tension, highlights a discrepancy. Different measurement techniques yield slightly different values for this expansion rate, hinting at either new physics beyond our current models or subtle systematic errors in our observations. This scientific mystery underscores that our understanding of cosmic expansion is still evolving, a testament to the dynamic nature of scientific inquiry. To further clarify how we measure and conceptualize these immense cosmic distances in an expanding universe, cosmologists use two key terms: co-moving distance and proper distance. Co-moving distance essentially refers to a coordinate system that expands along with the universe. Imagine a fixed grid laid across the cosmos. Galaxies might move slightly within their local clusters, but their co-moving coordinates remain relatively stable. Proper distance, on the other hand, is the distance between 2 points as measured by a ruler at a specific moment in cosmic time. As the universe expands, the proper distance between two co-moving points increases. So, while the co-moving distance to a distant galaxy remains constant, its proper distance from us continually grows due to the stretching of space. This means that a galaxy that is now, in terms of proper distance, 46 billion light-years away, was much closer in the past, even though its co-moving coordinates have not changed. The existence of a cosmic event horizon, driven by dark energy, means that there will come a time when all galaxies outside our local group will have receded beyond our ability to ever observe them, even in principle. Their light will simply be unable to overcome the accelerating expansion of the intervening space. This is a profound form of cosmic isolation. Future civilizations, billions of years from now, might gaze upon a night sky almost entirely empty of external galaxies, having no direct knowledge of the vast interconnected cosmos that we currently perceive. Their observable universe would shrink to encompass only their immediate galactic neighborhood. This thought, while perhaps a touch melancholic, also offers a deep, quiet sense of wonder about our fleeting moment in cosmic time. We are privileged to live in an era paints our skies and fills our telescopes. Our ability to map the cosmos, to study its expansion, and to even conceive of its ultimate fate is a unique gift of our epoch. It is a reminder that our understanding is a temporary window into an eternal process, a brief period of clarity before the cosmic veil of accelerating expansion gradually descends, obscuring the distant tapestry of existence. To contemplate this is to find a tranquil appreciation for the present, for the light that still reaches us, and for the profound interconnectedness we share with a universe that is forever expanding, forever unfolding its mysteries, inviting us to simply be present in its grand, silent dance. We have contemplated the profound cosmic event horizon, a boundary from which light emitted today will never reach us, a testament to the accelerating expansion of space itself. This acceleration, as we know, is attributed to dark energy, a mysterious component that constitutes roughly 68% of the universe's total energy density. Yet, despite its overwhelming influence on the cosmos, dark energy remains one of the most enigmatic entities in modern physics, a profound puzzle that challenges our deepest understanding of reality. It is not a force in the conventional sense, pulling or pushing on individual objects, but rather an inherent property of space itself, a pervasive pressure woven into the very fabric of space-time that causes it to stretch. The most straightforward explanation for dark energy is a reintroduction of Einstein's cosmological constant, a term he initially conceived to maintain a static universe. This constant suggests that even empty space possesses an intrinsic, non-zero energy density, which, unlike matter or radiation, does not dilute as the universe expands. Instead, as new space is created, more of this vacuum energy simply comes into existence, maintaining a constant energy density across the cosmos. This constant density of repulsive energy ensures that the acceleration of expansion continues unabated. However, the theoretical value predicted for this vacuum energy by quantum field theory is astronomically larger than what astronomers actually observe, by a staggering factor of about 120 orders of magnitude. This immense discrepancy, often referred to as the cosmological constant problem, is arguably the greatest unsolved mystery in physics, suggesting that our understanding of the quantum vacuum, or gravity, or both, is fundamentally incomplete. This profound fine-tuning problem leads scientists to explore alternative theories for dark energy. One such theory proposes quintessence, a dynamic, evolving energy field that permeates space. Unlike the cosmological constant, which is fixed, quintessence could change over time, its properties varying throughout cosmic history. Such a dynamic field might offer a more nuanced explanation for the observed acceleration, potentially allowing for different future scenarios for the universe, beyond a simple heat death. Perhaps this field would eventually decay, or its repulsive nature might strengthen further, leading to even more extreme cosmic fates. While no direct evidence for quintessence has yet been found, the concept highlights the ongoing intellectual quest to comprehend the fundamental nature of this cosmic accelerator. It is a testament to the ingenuity of theoretical physicists who continue to craft elegant mathematical frameworks in an attempt to capture the elusive essence of the universe's most dominant, yet unseen, component. The very existence of dark energy forces us to reconsider the fundamental constituents of our universe. Our familiar world of stars, planets, and galaxies made of ordinary matter comprises only about 5% of the cosmos. Dark matter, another invisible component, accounts for roughly 27%, providing the gravitational scaffolding that holds galaxies and galaxy clusters together. The remaining 68% is dark energy. This means that nearly 95% of the universe is composed of entities we cannot directly observe and whose nature we do not fully understand. We are, in essence, living in a cosmos dominated by shadows, guided by forces that remain largely hidden. This realization can evoke a sense of quiet humility, reminding us of the vast expanse of knowledge yet to be uncovered, a silent invitation to continue our scientific exploration. The accelerating expansion, driven by dark energy, also has profound implications for the future of scientific discovery itself. As distant galaxies recede beyond our cosmic event horizon, their light will eventually become undetectable, effectively isolating our local group of galaxies from the rest of the universe. Future astronomers, billions of years from now, might observe a largely empty sky, leading them to fundamentally different conclusions about the universe's origins and its composition. They might never know of the billions of galaxies that once populated the observable cosmos, or even the evidence for the Big Bang itself, as the cosmic microwave background radiation would also be redshifted beyond detection. This thought is a powerful reminder of the unique, temporary window of observation we currently inhabit, a privileged moment in cosmic history where the universe's grand narrative is still largely accessible to us. And as you reflect upon this cosmic dance, this interplay of visible matter, unseen dark matter, and the pervasive, accelerating push of dark energy, consider your own place within it. Your physical being, your consciousness, exists within this intricate balance of forces on a planet orbiting a star in a galaxy that, for now, remains gravitationally bound. The very fact that you are capable of contemplating these profound mysteries, of asking, what is the universe expanding into, is a remarkable consequence of cosmic evolution. You are a conscious manifestation of this universe, a temporary arrangement of atoms that has, for a brief epoch, the capacity to observe and wonder at its own grand, expanding story. This awareness can bring a tranquil sense of connection, a feeling of being an integral part of this vast, dynamic, and endlessly mysterious cosmos, gently drifting towards sleep with the quiet hum of the universe's expansion as a lullaby. Cosmic event horizon, a boundary that will ultimately sever our ability to observe distant galaxies due to the relentless, accelerating expansion of space itself, driven by dark energy. This concept, so deeply rooted in the physics of our universe, leads us to a fascinating and perhaps melancholic reflection on the impermanence of our cosmic view and the very nature of information across vast stretches of time. For our descendants, billions, even trillions of years into the future, the night sky will appear profoundly different, a testament to the dynamic evolution of reality. Imagine a time far, far from now when the light from galaxies beyond our local group has been stretched into oblivion, redshifted past any hope of detection. Our galactic neighborhood, including the Milky Way and Andromeda, will have merged into a single, colossal galaxy, a lonely island in an otherwise vast, dark ocean of expanding space. Future astronomers, if they exist, would gaze out into an almost entirely empty cosmos. The evidence for the Big Bang itself, the cosmic microwave background radiation, would also have been stretched to such extreme wavelengths that it too would be undetectable, fading into an unrecoverable whisper. They would have no direct observational proof of a universe teeming with billions of other galaxies, nor the telltale relic radiation of its fiery birth. Their cosmological models would be built upon a much smaller, more isolated universe, potentially leading to radically different conclusions about its origin, its size, and its ultimate fate. This slow erasure of cosmic history is a profound consequence of space's accelerating stretch, a testament to the fact that even information, in a sense, can be lost to the cosmic currents. This unfolding cosmic isolation invites us to appreciate the unique temporal window in which we currently exist. We are living in a privileged epoch, a fleeting moment in the universe's 13.8 billion-year history, where the light from countless galaxies, stretching back almost to the Big Bang, is still accessible to our telescopes. We can observe the early universe, witness the formation of the first stars and galaxies, and trace the evolution of cosmic structure. This ability to piece together the grand narrative of the cosmos, from its inflationary birth to its accelerating present, is a rare opportunity that will not be available to all future sentient beings. Our current understanding of the universe's expansion, its geometry, and the mysteries of dark energy and dark matter is a product of this fortunate observational vantage point. The very concept of now also takes on a more complex meaning in an expanding universe. In our everyday lives, we intuitively understand a shared present moment, a universal now that applies to everyone simultaneously. However, Albert Einstein's theory of relativity taught us that simultaneity is relative. What one observer perceives as simultaneous, another in a different state of motion might see as occurring at different times. In a universe where space itself is stretching, this relativity is amplified. The expansion means that the cosmic clock ticks differently across vast distances, influenced by the local curvature of space-time and the global expansion. There is no single, absolute cosmic present that encompasses all events across the entire universe. Each observer experiences their own now, a localized slice of space-time that shifts and tilts depending on their position and motion within the expanding cosmic fabric. This personal, relative nature of time, intricately linked to the expansion of space, reminds us that our individual experience of reality is deeply interwoven with the universe's grand dynamics. And as you consider this profound relativity, this unique window of observation, and the eventual isolation that awaits future cosmic inhabitants, perhaps a sense of tranquil wonder settles upon you. You are, at this very moment, a conscious participant in the universe's ongoing story, a brief but brilliant flicker of awareness within its boundless, expanding expanse. The questions you ask, the knowledge you seek, are part of the universe's own journey of self-discovery. The expansion of space, driven by dark energy, is not merely a distant physical phenomenon. It is an intimate part of your reality, shaping the very limits of what can be known and seen. This profound realization of our transient yet deeply connected place within the cosmic unfolding can offer a quiet sense of peace, a gentle invitation to let go of the need for absolute certainty, and instead embrace the beautiful, expanding mystery of existence itself as you drift towards a restful sleep. As we gently draw our reflections to a close, having traversed the boundless concepts of cosmic expansion and the profound limits of our perception, we are left with a sense of quiet awe. The universe, in its majestic unfolding, is a testament to change, to growth not into an external void, but from within its own intricate fabric. We have contemplated the invisible hand of dark energy, steadily accelerating the cosmic dance, gradually isolating future observers within their lonely galactic islands. Yet this very realization imbues our present moment with an extraordinary significance. We exist in an epoch where the echoes of the Big Bang still resonate, where the light from countless distant galaxies continues to paint our night skies with stories from across billions of years. We are given the rare gift of witnessing the universe in its vibrant maturity, a period of rich, accessible information before the cosmic event horizon inexorably draws its veil. In this quiet understanding, we might find a deep sense of peace. The universe does not demand our comprehension of every secret, but rather invites our contemplation of its boundless mysteries. You, a conscious part of this grand, expanding tapestry, are a fleeting yet precious arrangement of cosmic elements capable of asking these profound questions. Your own being reflects the dynamic, ever-changing nature of all existence. So, let these thoughts of endlessly stretching space, of hidden energies, and of our unique place in this cosmic story gently settle within you. May these deep thoughts about the universe's ceaseless expansion carry you into a world of tranquil sleep. Remember that the cosmos is an ever-unfolding wonder, and you are an intrinsic, beautiful part of its magnificent journey. Fall asleep with this feeling of serenity and endless knowledge. Good night.